So, working on solving a system of quadratic equations today, so we need to review a couple of things. One of those is simply solving a quadratic. So the thing that you need to remember is that in order to solve a quadratic, you have to be equal to 0. This can be done through the zero product property, or it can be done using the quadratic formula. So if you don't have the quadratic formula off the top of your head, you may want to write it down. Or sing it, if that's how you remember. Okay. Ryan, can you turn off that other light? It's a little bit glary. Okay. So on the first one can be factored, but I'm going to go ahead and do it with the quadratic formula, and then the second one I'm going to use the zero product property to show you guys both methods. So, we have an A of 1, a B of 7, and a C of 10. So x equals negative 7 plus or minus square root of 7 squared minus 4 times 1 times 10. If you write larger, you might want to do your work on a separate sheet of paper. It just depends. And then all divided by 2a, or 2 times 1. Negative 7 plus or minus 49 minus 4 times 1 times 10 is 40. So square root of 9. So 49 minus 40. All divided by 2. I'm going to go over because I'm going to run out of room going down. Negative 7 plus or minus 3. All divided by 2. And then I'm going to split this because generally when we're solving a quadratic equation, we're looking for the x-intercepts, and most, but not all, parabolas have 2 x-intercepts. So we split this into the plus, negative 7 plus 3, divided by 2. Negative 7 plus 3 is negative 4, divided by 2 is negative 2. That's one of my answers. The other answer is the minus part of that. So negative 7 minus 3 is negative 10. Divided by 2 is going to give us negative 5. So that is the quadratic formula. Keep in mind, once you have things in the quadratic formula, you shouldn't have any x's left, except for out in front. Everything else should just be simplifying from there. I want to run through number 2 as well, because a lot of people forget how to factor when you only have 2 terms. So 2x squared plus 16x. I could use the box and diamond to factor that, but it's a lot of extra work. So what can I look for instead? An x. So if I look at this, I'm looking for that greatest common factor, so I can factor it just using that. I can't do that with something like this, because I don't have an x with the 10, and 10 and 7 and 1 don't have a greatest common factor except for 1, which is not helpful. But I do have a greatest common factor for 2x squared and 16x, and that is 2x, because those are both divisible by 2x. Now, I want to be clear when I'm writing this, I'm not actually dividing them like I would both sides. I'm taking that 2x and putting it out in front. That's the factoring part. What I'm left with here on the inside is x, and then 16 divided by 2 is 8, and my x's divide out there. So this is just rewriting it. It's not doing anything to it. I'm just writing it differently. Questions on that? So now I can use the zero product property and just set both parts equal to 0. So I have 2x equals 0 and x plus 8 equals 0. So divide by 2, so x equals 0, and subtract 8, so x equals negative 8. solving a system algebraically. This is just a linear system, so there's not a lot of difficult things I have to do here. These are both equal to y, so I set them equal to each other. So 2x minus 3 equals 3x minus 2. So I'm going to take the smallest x from both sides, and then the x's are going to be over here, so I'm going to add this 2. So I have negative 1 equals x. That's my x value. And this is an important part because a lot of people forget it. Once I solve for x, what else do I have to do? I have to solve for y. So I can use either equation, so y equals 2 times negative 1, and plug that x in for, plug that negative 1 in for x. So y equals negative 2 minus 3, so y equals negative 5. So my solution, my point of intersection, is negative 1, negative 5. So today what we're doing is working on algebraically solving either two parabolas or a line and a parabola. So this particular one has a line and a parabola. So I'm going to use the equal values method again. These are both equal to y, so I'm going to set them equal to each other. There's x squared minus 4x plus 1 equals negative 2x plus 4. So, because I'm solving a quadratic, I have to do this a little bit differently. It's not that I can get all the x's to one side and the numbers to the other. What do I need to do? I need it to equal 0. So I'm going to get everything, and this is the easiest stuff to move. I would, if at all possible, keep your x squared on the positive side, because if you move your x squared over to the negative side, people tend to make more mistakes with that. So I'm going to take everything and put it over here. So I'm going to add 2x and subtract 4. So then what I'm left with is x squared minus 2x minus 3 equals 0. And you may very well find that you're going to need another sheet of paper for this, because there's not a lot of space on these. So, this one can be factored. So, I'll go ahead and go the long way about factoring it. Some of you can do it just shorthand, that's fine. Don't feel like you have to write this down if you know the process well. So x squared, so first term, last term, multiply those together. The middle term goes down here. And I'm looking for my factors of 3 that add up to negative 2. So 1 and 3 are my only factors of 3. I need the bottom to be negative, so I'm going to have a positive 1x and a negative 3x to add up to negative 2x. So those go in the boxes. Whoops. Negative 3x, 1x, x times x times 1 equals 1x, and x times negative 3. So I can rewrite this. And if it can't be factored, then you can just use the quadratic formula. Either way is perfectly fine. If you don't want to waste the time trying to factor it, if it's not going to be factorable, then just jump straight to the quadratic formula. That's an option as well. So x plus 1 times x minus 3. Use the zero product property, so whatever makes this one 0, so x equals negative 1. Whatever makes this 0, so x equals 3. Am I done with this problem? No, I am not. Why not?
Why not?
That's terrible. I have to find y. I have a system of equations here. I'm looking where these points cross. Where this line and the parabola cross. So I need both x's and y's for both of these. So I take my x values, and I'm going to do this separately, and I'm going to plug them into the line because I think that's a little bit easier too. It doesn't matter which equation you plug them into. So for the first one, I'm going to go ahead and do y equals negative 2 times negative 1 plus 4. So I'm using this x for that. So y equals 2 plus 4, so y equals 6. And over here, I'm going to take the same, I'm going to use the linear equation again. Negative 2 times 3 plus 4, so y equals negative 6. Let me write my negative more clearly. Plus 4, so y equals negative 2. So, I have 2 points of intersection. Those points are negative 1, 6, and these two, and 3, negative 2. You have to be able to show your work for that, but I do want to show you how to check that on the calculator if you don't already know. You can also check it algebraically by putting both x's into the quadratic and making sure you got those y's out. But do this, so x squared minus 4x plus 1, negative 2x plus 4, graph. We have our parabola and our lines. And there's ways to trace it and look more clearly, but our points of intersection we found to be negative 1, 6. So if we go over to negative 1, up 6, we're crossing there, and 3, negative 2. So you can trace it and you can zoom in and find your more exact points. There's also a way to calculate it on the calculator, but you can be roughly certain you're in the right place anyway.
You just type that in.
No, not if you want full credit, or any credit for that matter. You have to show me you can do it algebraically. Other questions on that? Alrighty. So, remember when you're solving a quadratic, you have to get everything equal to 0. Also keep in mind you are solving a system here, so you need to find both x's and both y's. I will finish up the key on here and let you guys work, and if you need any help, please ask questions. You should be able to finish a good portion of this, if not all of it, by the end of the period.